training system consists of three parts. The first part is electrical hanging boxes, and the second part is pneumatic components, and the third part is air compressor right here. I'm going to start with the electrical hanging boxes. Right here we've got an AC power supply. It uses a 220 volt. When I turn on this QF switch right here, the green light turns on right here, which is the indicator. These terminals right here, they conduct electricity. Supplies an AC 220 volt to DC power supply right here. DC power supply conducts the 220 volt and convert it to 24 volt, DC 24 volt. Of terminals and the fuse, and also it's got a button right here which is used to control the 24 volt output. It's got a terminal right here which is a positive 24 volt and a 0 volt right here. And beside we've got relay modules which consist of relay coils and relay contacts. Right here this is a relay coil. We've got a terminal, this is 24 volt and this is 0 volt. This is a normal closed contact right here, this is a normal closed contact right here, and this is a normal open contact right here, and this is the public end right here. When you connect this, it is normally closed, and when you connect this, it is normally open. These two are identical, they are the same. And beside we've got button group right here, which consists of three kinds of buttons. Right here, this is the red button, this is the yellow button, and this is the green button. These two buttons right here, they are self-resetting buttons, and this green button right here is a self-locking button. Each button right here has a normal open contact and has a normal closed contact. Also it got a lamp indicator right here. These two button group are identical. It's got a 20 volt source right here and it's got a 0 volt source right here. And secondly, we go to the pneumatic components. Right here we've got a simple acting cylinder. We've got a double solenoid 5-way 3-position directional control valve. This right here, they are all identical. They are all double acting. They are all double solenoid 3-position 5-way DCV, which is a directional control valve. And here we've got a single solenoid DCV, which is a 2-position 3-way DCV single solenoid. Here we've got a manual DCV, which is a 2-position 5-way manual control type. Here we've got a pneumatic reverse valve right here, which are identical for 1, 2, 3, 4, 5. Here we've got pneumatic triplets, which consist of pressure relief valve and oil mist and air filter. And right here we've got pressure reducing valve. This is a one-way throttling valve, stroke valves. Right here, this is a knob type DCV, which is a 2-position 3-way knob type directional control valve. And this is knob type DCV, which is a 3-way 2-position DCV. This right here, these are hand valves. This right here, these are on valve. This is a quick exhaust valve. Right here, this is a mushroom head button DCV. 5-way 2-position mushroom head button DCV. And right here below we've got air distribution, which distributes air to required components. And right here we've got stroke valve. This and this right here are identical. They are the same. They serve the same purpose. And right here we've got sensors, which are of 3 types. And right here we've got double acting cylinder. You can see right here, this is a double acting cylinder. We've got the last component, which is air compressor. This right here is a control button. It controls the start and the stop. When you want to start this air compressor, when you want to start this air compressor, all you have to do is just up right here. And then when you want to stop it, all you have to do is press the button down. It stops. And right here, this is a pressure gauge. When it reaches a certain level, air pump stops pumping oil. Right here, this is the valve which connects to the pneumatic triplets.
Hello, welcome to Dolang. I want to introduce you to our specially designed DLQD-DP201 basic electro pneumatic training system. This pneumatic training system consists of 3 parts, which are the electrical hanging buses, the pneumatic component, as well as the air compressor. It has a pneumatic triplet, which consists of an adjustable pressure reducing valve and the pressure gauge, as for air filter, which is used to filter out the moist in the pressure air in order to prevent this cylinder from damaging. It has an oil mist which supplies oil into the pressure air in order to make the cylinder to run smoothly. It serves as a lubricator. And right here we have the air distribution, which has an inlet port and 8 outlet ports. It distributes the pressure air to various components. Right here we have a DC. We have a double solenoid 5-way 2-position directional control valve. This is a port that is connected to the rodless cavity of the cylinder, and this is a port that is connected to the rod cavity of the cylinder. And right here, this magnetic switch, which connects the power source to the solenoid, it allows electricity to flow through the solenoid. When the solenoid absorbs electricity, and then DCV changes direction, making the cylinder rod to extend or retract. Let me introduce you to the demonstration motion of the double solenoid 5-way 2-position directional control valve controlling this A3 testing wire. The first you have to connect is the PE terminal on the AC circuit to the PE terminal on the DC circuit. That's the DC module, and then the L terminal on the AC module to the L terminal of the DC, and lastly the N terminal of the AC module to the N terminal of the DC module. When you switch this on and press this control button right here, which controls the output, 24-volt output, you can see this indicator turns on, showing you there is current flowing through the AC to the DC module. Like I said, you have to make sure this is off, and then turn this off, in order to avoid any danger for safety purpose. And then 0 volt right here is connected to a 0 volt terminal right here. And then the positive 24 volt is connected to a positive 24 volt. I want to get more testing wires. Then this positive 24 volt on the button group is connected to the open terminal of the self-locking button. And then the next thing I want to do is to connect the terminal on the button group to a magnetic switch. The terminal right here, normal open is connected. The terminal right here, normal open, is connected to the COM terminal right here on the magnetic switch. And then the other COM right here, terminal, is connected to the open terminal on the button group. The magnetic switch has 2 normal opens and 2 normal close. I want to connect this normal open to the positive terminal, 24 volt of this solenoid. I'll get more wires. Okay, I have one here. And then connect this one right here to the normal open right here. Now you can see connection is being made. And then next thing I want to do is to connect the air part. I want to make sure air flows from one component to another component. I want to get the hoses. First one you want to do is to connect the air switch to the distribution module, to the air distribution module. You have to make sure it's properly connected. And you can see this is connected to the inlet of the air distribution, and then this outlet right here is connected to the pressure port of DCV. And A port right here is connected to the rodless cavity of the cylinder, and the B port right here is connected to the rod cavity of the cylinder. You have to make sure there is proper connection to avoid air leakage. You have to test the gas part. You can see this is the air switch. Turn it to the left, it becomes open. And what you want to do next is to adjust the pressure reducing valve, which is adjustable. You pull this up and you set it to a pressure value which is 0.4 MPa to 0.6 MPa. Okay, this is okay. This is around 0.41 This is around 0.41. Then you close this, you lock it in. Then the next thing you want to do is to open this air switch to allow airflow to a distribution module. Next thing you want to do is to manually test this gas part. You can see it extends and then it retracts. This shows you there is no air leakage. The next thing you want to do is to turn on this, and then the next thing you want to do is, to turn on this QF switch right here on the AC module. When you turn this on, you can see the light indicator turns on, and power supply is being, and then power is being supplied, to a DC module, which is a 220 volt, and it converts it to a 24 volt output. You can see this is used to control, this button right here is used to control the output. You press this self-locking button, power is being transferred to this magnetic switch. When this button, power is being transferred to this magnetic switch. When this stroke right here is being pressed, contact is being made, there is flow of current from this source to a solenoid. And when the solenoid becomes energized, the DCV changes direction, and then the cylinder extends or retracts. 0 volt right here, you have to connect it to a 0 volt of DCV. You switch this off, and you connect this 0 volt to 0 volt right here, and then the 0 volt terminal right here to 0 volt terminal right here. You switch this off and you turn this on. Then you turn this right here, you turn it on. You can see it extends and it retracts. This keeps going on and on and on, making it automatically operated until this button right here is being pressed, which is a self-locking button. When you press this, it turns off. And when you press this, it turns on, and it keeps working and working and working, automatically operates. Lastly, when you are done with the testing, you turn this off, and as well you turn this switch off, and then lastly you remove every wire from the terminal. Neatly and gently put them in storage. And lastly, don't forget to off this first so as to stop airflow through the system, and then you'll be able to remove the hoses. You can see right here, you gently pull this out. You press this right here and you pull the hose out. You can see this. So easy. So you can see you don't have to use force. All you have to do is just press this right here. You can see, okay, you pull this right here, press this as well, and you'll be able to pull this out, and then press this right here, and then you'll be able to pull this hose out, and then you press this, you'll be able to pull this out. And they press this, you'll be able to pull this out. And you can see everything is perfectly made. So this is how you operate this specially designed DLQD-DP201 basic electro pneumatic training system. So easy and it's so efficient. Thank you very much.
Hello, welcome to Dolan. In this experiment, I want to introduce to you the working principle of quick exhaust valve. With the use of quick exhaust valve, the cylinder runs the track so far. So I'm going to show you how it works. Next you want to do is to press this push button right here. You can see it extends, and you can see it retracts so fast. So with the use of the quick exhaust valve, it retracts so fast. The cylinder retracts so fast.
This is the working principle of quick exhaust valve. Thank you.
Hello, welcome to Dolan. In this experiment, I want to show you the working principle of all valve, which operates by receiving an input from either of the push button. A port connects to the pressure, which is higher, which is the all valve, and the P port right here connects to the air distribution. So I want to show you how it works. After you're done with the air part connection, next what you want to do is to make sure everything is properly plugged in to avoid air leakage. Next what you want to do is to open the air pressure and increase the pressure. And then you lock. And now next what you want to do is to press either of this button. You can see when you press this button right here, it extends, and when you release it retracts. Either when you press this button right here, it extends and it retracts. And when you press both buttons, it extends as well and it retracts. So this all valve right here operates by receiving inputs from either P1 or P2. This is the working operation of all valve. Thank you. Hello, welcome to Dolan. In this experiment, I want to show you the working principle of hand valve, which is also known as dual pressure valve. This valve operates by P1 and P2 constantly supplying pressure to DCV. P1 and P2 press at the same time. Air is being supplied to the hand valve and P2 operates. So I want to show you how it works. After the air part connection, next one to do is to make sure everything is properly. After the air part connection, the next one to do is to make sure everything is properly plugged in to avoid air leakage. The next one to do is to open the pressure reducing valve and increase the pressure. When it reaches that pressure, which is 0.2 right here, when it reaches that pressure, next one to do is to lock this in. Now next what you want to do is to press this button at the same time. When you press this button, you can see it doesn't open. When you press this one as well, it doesn't open. You have to press these two buttons right here, then you can see it extends. When you release these buttons, it retracts. So it works by constantly supplying pressure at the same time to this hand valve. So you can see when you press this, it extends. When you release, it retracts. When you press either of these buttons,
it doesn't operate, so you have to press at the same time. This is the working principle of hand valve, which is also known as dual pressure valve. Thank you. Bye.
Hello, welcome to DLQD. Let me introduce the demonstration motion of manual shuttle directional control valve, which is a 5-way 3-position center closed directional control valve controlling a double acting cylinder with an inductive sensor. This sensor right here senses a metal in the system. Here you can see it got a clip right here which one attached to the board. Before you attach this to the board, you have to make sure this rod is being extended out so as to put in the right position. You don't have to make it too close and you don't have to make it so far. So you can see there's a little space between both, and then you pull this to the right, making it to retract. Next you want to do is to connect the electrical component, the electric circuit, to the inductive sensor. Firstly, you have to make sure this QF switch right here on the AC module is off in order to ensure safety. And the first terminal you want to connect is the PE terminal. To the PE terminal on the DC module, and the next terminal you want to connect is the L terminal to the L terminal of DC module, and lastly connect the N terminal to the N terminal. Then next you want to do is to connect the relay with the DC module, 24-volt module. You can see this is connected to a 0 volt and this is connected right here to 0 volt. And 0 volt right here is connected to a 0 volt right here. And 24 volt right here is connected to a 24 volt right here. And the relay coil right here, the terminal of the relay coil right here is connected to the out terminal right here of the inductive sensor. And lastly, I need a shorter wire now to connect this terminal. 24 volt right here of DC is connected to 24 volt of the button group. And then 24 volt right here is connected to 24 volt of the relay module. And then this is connected to the 14 terminal of the relay module. Then the public end on the relay module is connected to the light indicator, and 0 volt is connected to 0 volt right here on the 24 power module. And lastly, what you want to do is turn on this QF switch, and then you turn on this button right here which controls the 24 volt output. And you can see this turns on, indicating to you that power flows through this 24 volt module. And yeah, lastly, what you want to do is to check the pressure gauge to see if this set value is up to the required value. You want the value to be adjusted to 0.4 MPa or 0.6 MPa, or lies between 0.4 to 0.6 MPa. You pull this up and then you adjust the pressure gauge to the required value. After adjusting the adjustable pressure valve, then you lock it in, and then you open the air switch, making air flow through the air distribution and then to the DCV, directional control valve. The next you want to do is to pull this to the left, making this extend, and you can see it indicates to you that a metal is being sensed over there. Then pull this back, it retracts. So you can see this inductive sensor is used to detect metal in the system. Hello everyone, welcome to DLQD. Let me introduce you to a demonstration motion of manual shuttle valve controlling double acting cylinder. Right here with me I've got the manual shuttle valve, which is a 5-way 3-position directional control valve, center closed. You can see right here this is the undo, this is the P port, and this is the outlet port. And you can see right here it's got a clip which you can use to clip on the board. Right here I want to clip this right now. You can see it's clipped. It's clipped. And right here I've got the air distribution module which has 1 inlet port and 8 outlet ports. And that's why it's got a clip right here. And right here I've got the double acting cylinder which has 2 ports, the inlet and the outlet port. And right here you can see it's got the clips as well I'll clip this on the board. I've got the hoses which I want to use to connect the pneumatic component. Firstly, you connect this air switch to the air distribution module, to the inlet of the air distribution module, and then the outlet port to the P port of the DCV, manual shuttle directional control valve, 5-way 3-position center closed. And right here the A port connected to the rodless cavity of the cylinder, and then the B port connects to the rod cavity of the cylinder. Now to make sure there is proper connection and to avoid air leakage, you have to make sure this is properly fixed in. It's all set. And then what next you have to do, you have to make sure the pressure gauge is set to 0.4 to 0.6. You can rotate this in order to regulate the pressure. When it reaches the required pressure value, you lock this in. And you can see this is the air filter which filters out the moist in the pressure air, and this is the oil mist which supplies oil into the pressure air, thereby making this cylinder to operate smoothly. When you open the air switch, there's airflow through the air distribution to the P port of the DCV, directional control valve, and then to the ports which connects to the cylinder. Push this manual handle right here to the left, you can see it extends, and when you push it to the right, you can see it retracts. So you can see this way, this is how to use the manual shuttle directional control valve, 5-way 3-position DCV. You can see right here when you push to the left it extends, and when you push to the right it retracts. And then you bring it back to a centered position and it remains closed. And yeah, lastly, what you want to do after you're done with the experiment, the first thing you want to do is to make sure the switch is closed, air doesn't flow to the air distribution, and air doesn't flow to DCV, and air doesn't flow to the cylinder. And then if you want to remove this hose, all you have to do is to press this right here, this clip right here, and then you'll be able to remove this gently. You'll be able to remove this as well, and gently. You'll be able to remove this, and gently remove this, and gently remove this. This is how to use the manual shuttle valve to control the double acting cylinder.